Course objectives. So the main goal of this course is for you to understand what is Aspen Plus, why do we need it, and why it's so helpful for us process engineers in the design, operation, and optimization of plant or chemical plants. You might be in the chemical industry, you might be in the petrochemicals, you might be in fine chemistry, and so on. The important task right here is to understand what type of industries are used in Aspen Plus, what type of unit operations you can model, and eventually what I want you to understand is how can you model several chemical processes. Okay, for this we will need the understanding of the physical property environments, just the basics. How can we set up the property methods, the components, reactions, and all the models, equations, if it's going to be treated as ideal state or real state, ideal solution, so on. All these methods, even though it's very easy for us, for Aspen makes it very easy, we just select the method and all is going to be calculated automatically, but it is very critical to select the correct method. Also, we're going to see some plotting tools there, such as the temperature versus composition diagrams, pressure versus composition, and so on. Then also, I want to work on the flow sheeting, which is essentially how to build your flow sheet. Flow sheet is the main area where you work. So once you fill up the physical property environment, you go to the simulation environment. So you got here the navigation pane, and this area where you are going to be adding your unit operations, the reactors, the pumps, and so on. All this is called the flow sheet. And what I want to show you is not only how to add the basics, such as streams, blocks, units, so on. I want to show you how you can improve your flow sheeting techniques in order for you to get better results, easier optimization, easier analysis, better understanding of your process to manipulate correctly the flow sheet. We're going to see also how to run the simulation, how to present results either of a block or of a stream, how to plot several relevant data, such maybe if you're talking about a reactor, you want to see the reaction of extent, how reactant is decreasing in concentration, how products are increasing in concentration. Maybe if you're talking about batch reactor, you're talking about time, composition, length of the reactor, if you're talking about PFR, and so on. Also, as stated before, it's very important for you that we are going to be working on case studies and workshops. So all these are based on chemical processes, real life processes that are extensively used in the chemical industry. Also, as stated before, guys, the more unit operations you get to know, the more processes you will be able to model. So one very simple example is many people don't understand the use of SEP 1 or 2. And this is typically used when you have a membrane or a filter, special condition, anything that can be used for separation that cannot be modeled with Aspen Plus. So for instance, a good example is a membrane. Even though you might add a user model and try to model a membrane, it's much easier if you know the composition. Maybe some membranes are straightforward. You know that 100% of X is going to be separated. So you select it here. Sometimes you don't have that much specifics, but you can add them to the separator. So even though you don't know how to model a membrane or a filter, you can use these the more unit operations you know here, or essentially the more blocks you know from Aspen Plus. I also want to add a very important part, which is how to converge correctly distillation columns or iteration processes, because sometimes it's a pain that it typically happens when you're running a simulation and then something is broken. It might be stupid things such as you didn't prepare the physical property environment, there's a line missing in the title, or maybe even you typed CO2, you're using maybe carbon monoxide, and of course the reaction is incorrect. So even though you think you're using CO2, you are using CO, so of course there's going to be a mass balance error, energy balance error, stoichiometric error, and so on. Those are easy to get also when you are stating columns or flashes. The important part is to understand what's happening and fix it, because sometimes it's kind of hard with typically you get a report on how Aspen is running all the processes, equations, and so on. But sometimes it's really hard to understand what's the error, what's happening. So here is where we're going to check out how to converge and how to debug. Sometimes you're going to have warnings, which are shown as yellow. Typically, these are, let's say, even though not that strong errors, they must be attacked. You must understand what's happening. Common warnings are the normalization, which is essentially, even though you know that the total addition of the mole fraction must be equal to 1, this was maybe 95. So you know that this is not possible. But even though this is small error, what Aspen Plus does is to normalize all the values in order to fix this to a 1 or addition of 1. So typically you have, let's say, 10, 15, and 20. And this is not adding up to this is, let's say we want to add 50, but you know that this technically is 45. So what Aspen does is distributes evenly the missing 5 in order to get maybe, let's say 12, it will be 17.5, and this will be 2, 1. Well, actually this is much likely to happen. 16 and 11. So you have 11 plus 16 plus 23, you're going to have 50. So this is now correct. So that's what I'm talking about, warnings. And errors are of much more concern because those are essentially incorrect inputs, or maybe you just didn't converge. Aspen Plus finished iterations with no results. So these are kind of harder to get. And finally, also very important for process engineers and especially plant designers is how to calculate the utilities, the cost of heating, cooling, the cost of electricity, cost of raw materials, all the economics behind a plant. So we're going to see some economics analysis and plant design as well. Okay, so these were course objectives.